This is a Math 3 summary video for the lesson titled Finding Your Center. This lesson is a develop and solidify understanding task. The purpose of this task is for students to construct and discover the properties of centers of triangles. These centers include the centroid, incenter, and circumcenter. Let's start by going over the vocabulary. A point of concurrency is a point where three or more intersecting lines meet. A perpendicular bisector cuts a segment into two equal segments at a right angle. The circumcenter is the point of concurrency of the perpendicular bisectors of the sides of the triangle. A median is a segment that connects a vertex to the midpoint of the segment opposite of the vertex. The centroid is the point of concurrency of the medians of the triangle. An angle bisector cuts an angle into two equal pieces. The incenter is the point of concurrency of the angle bisectors in a triangle. Next, I'm going to use Desmos to construct each of these centers of a triangle. To find the circumcenter, I need to construct the perpendicular bisectors of the sides. So I want to start by finding the midpoint of each side. And then I'll construct perpendicular lines that pass through each of these midpoints. The point where these three perpendicular bisectors intersect is the circumcenter. This is the center of a circle that is circumscribed about the triangle. That means that the vertices of the triangle are on the circle and that the vertices of the triangle are equidistant to the circumcenter. Notice that when the triangle is an acute triangle, the circumcenter is inside the triangle. When the triangle is obtuse, the circumcenter is outside of the triangle, and when the triangle was a right triangle, then the circumcenter would be on the hypotenuse of the triangle. To find the incenter, I need to construct the angle bisectors of each angle of the triangle. To do this with Desmos, I take advantage of the properties of congruent circles. For each angle, the second and third circle that I construct must be congruent to each other, and their centers must be on the sides of the triangle. This ensures that the line that passes through the two circles' intersection points is equidistant to the sides of the triangle. To simplify the construction, at each angle I have constructed three congruent circles, where the first one's center is on a vertex of the triangle, and the second two circles have centers at the intersection points of the first circle and the sides of the triangle. After constructing the three angle bisectors, I find the point where they intersect, which is the incenter. The incenter is the center of a circle inscribed inside of the triangle. To be able to move the triangle around and make sure that the inscribed circle remains the correct size, then you need to construct a line that is perpendicular to one of the sides and passes through the incenter. Now, when you construct your circle, first click on the incenter to set the center of your circle and then the point of intersection between the perpendicular line and the side of the triangle. This will keep your circle attached to the side of your triangle and keep your radius the correct length. Make sure that you notice that when I change the shape of the triangle, the incenter remains inside the triangle. To find the centroid, I need to construct the medians of the triangle. A median of a triangle is a segment that connects the vertex of a triangle with the midpoint of the side opposite the vertex. So all I need to do is find each midpoint and then use line segments to construct the medians. The point of concurrency of the medians is called the centroid. Notice that as I change the triangle's shape, the centroid remains inside the triangle. The centroid breaks each median into a 2-to-1 ratio. So if we measure the distance from the midpoint to the centroid, that length is half the distance from the segment that goes from the centroid to the vertex. You can see here that 1.8 is half of 3.6. With the Desmos program that I'm using, the measurements are rounded, so it's okay if the lengths seem like they're almost in a 2-to-1 ratio. If we had perfect unrounded measurements, then they would be perfectly at a 2-to-1 ratio. There are a few other interesting facts about the centroid. The centroid is the center of gravity of the triangle. So if we cut out the triangle and wanted to balance it on the tip of our pencil, then we would want to place the tip of our pencil on the centroid. Also, all three medians drawn together in the triangle break the triangle into 6 triangles that have the same area. To summarize, the circumcenter is the point of concurrency of the perpendicular bisectors of a triangle. It's equidistant to the vertices of the triangle and the center of the circle that circumscribes the triangle. The incenter is the point of concurrency of the angle bisectors of a triangle. It's equidistant to the sides of the triangle and the center of a circle inscribed inside of a triangle. The centroid is the point concurrency of the medians of the triangle. It divides the triangle into 6 triangles that have equal areas. It's the center of gravity for the triangle, and it's located 2/3 of the way along each median. All right, that's it for this video. Thank you for watching.